Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is check whether BST contains dead end, and it is going to be an easy level problem. So they have said that a binary search tree is a tree which contains unique positive integer values greater than 0, and our task is to compute a function whether there is a dead end or not. So a dead end is a leaf node where we cannot add any other node, right? So this is what they say, and obviously we would want to solve this problem in O of n space and time as well. Now if you have a look at the values of the nodes, it is up to 10 raised to the power 4 roughly. So how do we check this? We know that if I have a binary search tree, that all the values smaller will come to the left and all the values bigger will come to the right, right? Why there is no value equal to? Because they have specifically mentioned that it is going to contain unique positive integer values, right? So what will happen? Let's say I have a value x here, right? And the minimum and the maximum value that I can have on this range is, let's say, minimum value is 1 and maximum value is 1 0 0 0 1, right? So this is the range that I have. So this is the minimum value I can have inside this whole subtree, and this is the maximum value that I can have inside this whole subtree. So now let us talk about this particular node and its subtree, right? So it will have some children, right? So I'm not drawing the proper subtree, but what will happen now? The minimum value will still remain 1, but the maximum value will now be x minus 1, because all the values in this left subtree should be smaller than x. Similarly, here if I go to the right subtree, I'll have some node and I'll have some children. So now the maximum value will still remain as it is, but the minimum value will become x plus 1, right? So you see that when I enter any subtree, my maximum and my minimum values are going to change. So when is the case when I cannot add any nodes to a particular node? So let's say I have a node y, and when will it be the case when I cannot add any further nodes here, right? This is the thing I have to figure out. Once I know what is the maximum and the minimum values allowed in this whole subtree, I can figure out whether I can add more nodes or not, right? So let's consider a case where the current node value is y, the minimum value I can add is y, and the maximum value that I can add is also y. So in this whole subtree, y is the minimum value, y is the maximum value, and y is the value of the current node. That means I cannot add a value smaller than y, I cannot add a value bigger than y, so I am trapped on both sides, right? So this type of node will be known as a dead end, right, according to the problem statement. So this is exactly what we have to figure out. What we can essentially do is, we know the initial range is this one, right? And you have to be very careful about the initial range, because the minimum value should be 1 only, right? The maximum value can be anything, but the minimum value you should be taking care of it, that it should be 1, right? Now how do we solve the problem then? We just have to form a simple recursive function, and the base case should be when node is equals to null pointer, right? So this is one of the base cases. In this base case, we will just return false, right? Because we have not found a dead end yet and we have reached a null pointer. The other base case will be that the current node data is equal to the minimum value and the current node data is equal to the maximum value. That means we have reached a dead end, and in that case we are going to return true, right? Return 1. And if none of them is possible, none of them are executed, then what we can do is we can return a traversal of the left subtree, or bitwise, or logical, or a traversal of the right subtree. That means I am going to find for a dead end in the left subtree, and I am going to find a dead end in the right subtree. Even if I find one dead end in one of them, that means I am going to return true. So this was the whole logic of this particular problem. Let me show you the code here. So again, this like the smaller value is very important, because they have specifically mentioned that there will be only unique positive integer values, right? And so this is the range that I have taken, minimum and maximum. And what I do, if not node, that means if node is equals to null pointer, I am going to return 0. And if no data is equals to min and no data is equals to max, that means this is going to be a dead end. In that particular case, I am going to return true. Otherwise, I am going to call the same helper function on the left half and call the same helper function on the right half. You see, I am also modifying the minimum and the maximum values for both left half and right half respectively. So you see, this is the modified value. So once they both return their results, I'm just going to take their logical OR, right? So in this isDone function, I'm just calling whatever this helper function is and returning the value returned by the helper function. So let me just quickly submit this and show you that this particular code works and the solution is absolutely correct. So you see possible test cases, and I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.